Good morning, folks. So I want to kind of rehash through some working with the basics of parabolas. I realized that even though we've seen parabolas before, because of the new types of equations, they have the potential to still be a little bit confusing. So there are two different versions of standard form. I'm fine with either one you want to use. One of them uses, they isolate a variable, whether it's vertical, they isolate the y, or horizontal, it gets the x by itself. The other form is a little bit more similar to the standard form for like a circle or an ellipse or a hyperbola, where it kind of has two different bundles of parentheses. So there are little benefits to both. It really makes no difference. Um, Familiarize with one or the other, I'm fine with that. And I will accept both on any quiz for this topic. So keep in mind though, vertical, the giveaway for a vertical parabola is the x component is being squared. If it's horizontal, the y component would be squared. And then depending on the value of p, or this coefficient 4p, or 1 over 4p, depending on which version you're using, that being positive means I'm going to be opening to the right or opening up. And if it's negative, I'm going to be opening downward or opening to the left. If you think about the x and y axes, a positive p opens in the positive direction of those axes. Okay, so I will scan and put this onto the course page as well, just like I have with the other reference ones in previous sections. Now, I have two examples I want to go over today. Hopefully get through them pretty quick. Uh, this should not be a surprise to you. Something in this form is nowhere close to standard form. So we want to first get this in standard form and then identify a vertex, a focus, and a directrix as such. So of course, this is going to be our completing the square example for this section. So before we do anything, I'm going to do a little rearranging. Of course, I can move the negative first. And I'm also going to factor out that -1 in front of or out of the x components. Because again, when you're completing the square, you don't want any coefficient on your leading term. So even though it's just a negative, I'm taking it out. And then I'm going to leave a space blank for completing the square on the x's. Now, I don't need to do that with the y terms because there's no squared y term. A parabola is only going to have one of the variables squared. Now, we don't know if it's going to open up or down, but we do know it's vertical because it's going to be an x squared equation. We have to wait until the final equation before we can see if p ends up being positive or negative. Now, completing the square, again, we're going to add a half your middle term squared. So half -6 is -3 squared, gives me 9. And I need to balance that over on the other side with a -9. Again, that 9 I added here, I'm really going to multiply by this factor of -1, and I now have a -9 there. So I have a negative quantity, x minus 3 squared, equals an 8y minus 8. All right, so it's starting to take shape. It's not quite there. What I want to do here is I'm going to put it in that second version. I'm going to put it in this version of my standard form, just to work with a different type of example today. So I'm going to have a negative x minus 3 squared equals, at this point, I'm going to now factor out this coefficient 8. Okay, so, and the reason being, it's x minus h and y minus k on the insides, so just one x, one y, no coefficient. If there's a coefficient, factor it out. And the last thing you want to do is in this version here, notice if the x is being squared, there's absolutely no coefficient in front of there. All the coefficient is in this other variable in front of the y. So this negative, I'm simply going to divide that over to the other side. And there we have um, my new coefficient, -8. So right away, we have our h and our k. So h is going to be 3, k is going to be 1. So my vertex is 3, comma 1. Now I didn't ask, but we can now say not only does it open vertically, it's going to specifically open downward, which is good to know because that tells me I'm going to, when I figure out my value p, I'm going to go, my focus should be below my vertex, and the directrix should be above my vertex. It's going to take the shape of directrix, vertex, focus, in that order. Okay, well, we already have 3, comma 1. Now, we know that that 4p is going to be my coefficient here. So of course p is -2. Again, though, the negative is already telling me it's going down. So this here is 2 units below. This focus is 2 units below the vertex. So my focus going 2 units down from my vertex is 3, -1. If I go 2 units above my vertex, I'm at a y coordinate of 3, which means my directrix is just simply y equals 3. Keep in mind, your directrix is a line. So you might first find the point that is above your vertex, but it's the y coordinate that's going to make it a linear equation. It's a horizontal line after all. Okay? So just be aware that I do not want a ordered pair for a directrix. I do want an equation. Now, and this is our last type of example you would expect to see in this section. Again, it should be pretty predictable here, the types of questions to expect. We're either going to work with coming up with equations or work with the equations and coming up with information. So it shouldn't be surprised that here is some critical information about a parabola. I'm giving you a focus and I'm giving you the directrix, and I want the standard form equation. So with parabolas more so than the rest, if you haven't already been considering this, just get a quick visual. It doesn't have to be anything near perfect for the graph. But for instance, I have a focus at 1, -3, and my directrix is x equals 0. So that's a vertical line at 0. Okay, so there's my directrix. So we right away know the point in the middle here is going to be my vertex. So keep in mind, I had to go a little bit one direction to get to the focus and a little bit the other direction to get to my directrix. So the point right in the middle of those two is going to be my vertex. So if this was at an x coordinate of 1, halfway between 1 and 0 is an x coordinate of 1/2. And then because I'm moving horizontally to get from one to the other, I'm not going to really change my y coordinate. So that's still going to be -3. So right away, my vertex is 1/2 -3. Okay. We also know because of the directrix and where the focus is, I can't open a parabola any way but to the right in order to avoid hitting my directrix. Keep in mind, the parabola never hits the directrix. If it was to open any other direction, it would intersect that. So it has to go to the right. So that means P is going to be positive and the y coordinate is going to be squared. So when I do my x minus h and my y minus k, I know my y term is going to be squared and my x term is going to have that coefficient 4p. And that's the last step we need to do is figure out that value p. So I'm just going to leave that blank for just a second. And let's talk about that. So again, we know two things. vertex to the focus, that's a value p, or vertex to the directrix is also a value p. So I know from the vertex, which is positive 1/2, to a focus, which was at positive 1 on the x, is a distance of 1/2. So then that means 4p is 4 times 1/2, or 2. And there's my standard form equation. Okay, there's quite a few of these to practice in the homework, so take some time today to practice that. Monday is going to be a nice little review of all of this, and then I'm thinking mini quiz on parabolas on Tuesday. So take some time over the weekend to finish up the homework on this section and reach out if you have any questions. Goodbye.